Okay, good morning, everyone. We learned about last lesson about rate of reactions, and we said any reaction that makes a gas, the total amount of gas made by the end of each minute shows how the rate of reaction changes over time. And we studied about how can we choose our apparatus and how can we plot our data and how can we calculate the rate of the reaction. Now we will study, or today we will study about the concentration and the rate reaction, the relationship between concentration and the rate reaction. So have you ever wondered about the concentration? If we increase the concentration of the substance, does it affect the reaction? Does it make it fast or slow it down? So we will see in this lesson how the concentration affects reaction rate. So at first, why do we need sometimes to speed up reactions? Sometimes we need to speed up reactions to get the product immediately. We don't need to lose more time or to spend more time or long time to get the product. So sometimes we need to use a substance to speed up the reaction. Sophie, are you there? Okay, can you tell me a substance that can speed up the reaction? What do we call it? What do we call this substance?
Catalysts.
Catalyst, thank you. Catalyst is a substance that can speed up the rate of the reaction, make it fast if it's slow. So sometimes, for example, if you want to produce medicines or make medicines, we need to make it fast or speed up the reaction. So we are using catalysts. Here, we have two students. They ask questions about reaction rates. So Junaid said, how can I make reactions faster? And Alor said, in acid reactions, what difference does the concentration of the acid make? Okay, to be able to solve these questions, we need to have our investigation or to make our investigation and predict, for example, first we need to predict. So students decide to investigate Allah's question. It's focused. Why it's focused? Because it's focusing on on how can we make it faster, not just like the difference of the concentration. So what makes it faster? And they can get an answer to the question in just 1 hour by making this investigation. So they were using the same apparatus, okay, nearly the same apparatus in the last lesson or the previous lesson, but here they need to add something else, which is the stopwatch. So here they used a conical flask and they used a measuring cylinder. So why they used a measuring cylinder, Sophie?
What did you ask, Ms. Hannah?
And why they used measuring cylinder here in their investigation?
Because they need like the measurements.
They need to measure it precisely, so it can measure small differences. Measuring cylinder can measure small differences, so they need to use this measuring cylinder. And they used conical flask to their reaction of hydrochloric acid and magnesium ribbon. So here, the student decide to investigate the reaction of magnesium with hydrochloric acid. As we mentioned in the previous lesson, gives us magnesium chloride plus hydrogen. Their teacher gives them the apparatus below. The student lists the variables in the investigation. So here, they have the time for magnesium ribbon to finish reaction. They have the amount of magnesium ribbon, concentration of acid, temperature, and volume of acid. Okay, these are their variables. So the students decide to change the concentration of the acid. So the concentration of the acid here, concentration of acid, this is which variable?
Independent.
This is the independent variable, okay, to change, and they will measure the time for the magnesium ribbon to finish reacting. So what do we call this variable? The measuring variable.
The dependent.
The dependent variable. Dependent variable, which is the variable that depends on the one that we change. Okay, this is depending on variable. So the time for the magnesium ribbon to finish the reaction depends on the concentration of the acid, the concentration of the acid. So whether is it diluted or concentrated acid. So here, they will keep the other of two variables constant so that their test is fair. So here the controlling variable, here they can control the other variables, which is the temperature, the volume of the acid, and the amount of the magnesium ribbon. The students wonder how much magnesium ribbon to use. They do some preliminary work to find out. This involves adding different lengths of magnesium ribbon to acids of different concentrations. They find the length of ribbon that reacts with the most and least concentrated acids in a sensible time. So this as a preliminary work, we said before, we need to use this as a primary step to define or to decide which length we want to use, which amount of acid we want to use, which concentration, because we don't waste, we don't need to waste a lot of materials or or use very large amounts. And in this case, we can save our investigation, save the material, save time for ourselves, okay? They need to present their evidence now. They have the results in a table, then they plot the data in their graph, line graph, because they used continuous variables, right? The time and what else? Sorry? The time and what?
The time and the
concentration. We have the time and the concentration. So concentration is different here and the time is different here. So both of them are continuous variables. In this case, we need to use, we need to present them in a line graph. Okay?
yes.
Okay, so now they plot their data in the graph, and they now consider, they wrote a conclusion for their investigation. They said the graph shows a correlation between acid concentration and reaction time. Okay, look at the graph here. Look at the graph here. I need you to find out the correlation between the time and the concentration of the acid.
What was the correlation exactly?
Like the relationship.
Like when it's 2, the time is lower. When the acid is more concentrated, the reaction time to finish is less. It finishes more faster if it's more concentrated.
So when we have here high concentration, this is low concentration here, 1, okay, and here 1.5, it's increasing, okay. As more as we increase this concentration, the time is getting less or decreasing. Why the time is decreasing? So look at this, it's decreasing, the time is decreasing from 80 seconds to 10 or 15 seconds. No, not 15, 18 seconds. So why the time is decreasing here?
Because the acid is getting more concentrated.
Okay, and this what makes the reaction, what will happen to the reaction? The reaction will happen fast. So it will,
It will react faster.
yeah, they will react faster. They won't take time, or they won't take long time to react together. So all the reactants will be used up quickly in a short time. So the correlation between acid concentration and reaction time, as acid concentration increases, the reaction time decreases. This means that when the acid concentration is higher, the rate of the reaction is faster because it doesn't take time. So here the students need to improve their conclusion. They must give a scientific explanation for the correlation. So they need to explain why the concentration increases or make the rate of reaction faster, or increases the reaction rate. So they need to explain about something, or what's happening exactly inside the reaction or inside the liquid. So what do you think here? For example, if we have, this is, for example, cup of water, and this is another cup of water, but no, let's not take this. I will give you this example. I have here full cup, and I have here quarter, or, okay, less than half cup. So I have here water inside it, and I have here the same thing, water. Here I have, for example, sugar, okay? And I have here sugar molecules also. Here I will get the same number of spoons. For example, I added 2 here and 2 there. Which one of them will dissolve more sugar inside it?
The one with the more water inside.
Okay, what's the reason here?
It's because there is more water, so there is more space for the sugar molecules to get mixed.
Yeah, because water molecules are higher or more than the water molecules in the second or in the first cup. So it's the same thing with here with the just let me get the mouse. The same thing is happening here with the concentration of a solution. So the scientific explanation for them, that the concentration of a solution tells you how much solute is dissolved in the solvent. So where is the solute here? Which one of them is a solute?
The magnesium ribbon.
The magnesium ribbon, thank you. And the solvent is hydrochloric acid. So the more concentrated of an acid solution, the greater number of acid particles dissolved in a certain volume of a solution. So here in this picture on the right, we have here more molecules and we have here less molecules. So the reaction rate will increase with the more concentrated solution. The substances only react when their particles hit each other. So when they get blend with each other, or when they hit each other or collide with each other, they will react and they will have a new substance. So the more concentrated the acid, the more frequently its particles collide with magnesium particles. So the faster the reaction here. So as more as you added here particles, I have here particles of the hydrochloric acid here, okay, more particles here, and here less.
They will touch each other more.
Yeah, they will be in contact with each other more and more, or they will hit each other, so they will react. So in this case, the reaction rate will get faster, or will be fast, okay? So this is the correlation between the concentration rate and the reaction rate. So for reactions involve solution, the more concentrated the solution, the faster the reaction. So this was all about the reaction and the concentration and the reaction. Do you have any question about this? Sophie, do you have any question? Sophie. Okay, Sophie, if you can.
No, it's all clear.
Okay, we have the yellow box, okay?
No, it's clear.
And we have the questions, okay, in page 220, the revision questions, 220, okay? We will start to solve these questions at home and correct them together here in our lesson, okay? Okay, so now we finished our lesson. Next lesson, we will learn about temperature and reaction rate, how the temperature can affect the reaction rate. Now we learned about concentration. Next time we will learn about temperature, how can the temperature affect the reaction rate, and the surface area can affect the reaction rate. And then we will learn about the catalyst, okay? So, time in a new lesson, guys.